Hello all, I am Dr. Pravas Chandanbal. In today's class, we'll discuss about the remaining types of what machine independent code optimization. Okay, so we have already discussed about 6 types of machine independent code optimization methods in the previous class. Okay, so in today's class, we'll discuss about the remaining types of what machine independent code optimization. Okay, the seventh the seventh machine independent code optimization method is okay loop invariant computation. Loop invariant computation, or we can say frequency reduction, or we can say code motion, or we can say code motion. Okay, loop invariant computation, or we can say frequency reduction, or we can say code motion. So what is the meaning of code motion? Try to understand the definition. Okay, see, a statement or expression, a statement or expression which can be moved, a statement or expression which can be moved outside of the loop, outside of the loop body without affecting the semantic of the program, without affecting the semantic of the program. This is very important. A statement or expression which can be moved outside of the program or outside of the loop body without affecting the semantic of the program. Try to understand the definition with the help of example. See, this is my code snippet. This is my code snippet. What for I equals to 0, for I equals to 0, I value is less or equals to 10, I plus plus x equals to a divided by b, a divided by b plus I. Okay, so this is one of my for loop. Okay, but when my I value equal to 0, I just take what I value equals to 0, I equal to 0 and 0 is less or equals to 10. My condition is true. My condition is true. That means this statement will execute. But in the statement, in the given statement, this statement will execute it how many times? Because here I value is less or equals to 10. That means the statement will execute. The statement will execute 10 times. The statement will execute 10 times. Okay, from 0, 1, 2 up to 9. But each time, this a divided by b will compute it. Each time a divided by b will compute it, or the division of a and b will compute it how many times? 10 times. But we can also optimize the given code snippet. How? Just see, we just assign or a divided by b, a divided by b in n outside of the loop. Outside of the loop, we just assign a divided by b in n and simply write what? For I equals to 0, I is less or equals to 10, I plus plus, so x equals to n plus I. That means this code or this loop will execute also 10 times. This loop will execute also 10 times. But this a divided by b, will compute only one time. Here it compute only one time, but here a divided by b will compute 10 times. Okay, so this is called as loop motion. This is called as code motion or loop motion. We can say a statement or expression which can be moved but outside of the loop without affecting the semantic of the program. Okay, so in the given code snippet means, in the given code snippet, a divided by b will execute how many times? 10 times. After optimization, a divided by b will compute only one time. We just assign this n value in here, means inside the loop. This is called as code motion. Okay, so next we'll see the next code, the next optimization method Next optimization method is what? Loop jamming. So what is the meaning of loop jamming? Just say combine the bodies of two loops. Combine the bodies of two loops. If there are two loops, we just combine. How to combine? Just see. This is one of my code snippet. What? For I equals to 1, I less equals to 100, I plus plus, and it will execute statement 1. This is one for loop. And the second for loop, just see, for j equals to 1, j value is less equals to 100, j plus plus, it will execute statement 2. Okay. So this is for means first for loop, and this is my second for loop. Okay. So in the first, just see the first and the second for loop. The first and the second for loop both are completely same. Both are completely same, but in the first for loop it will execute what? Statement 1, but in the second for loop it will execute statement 2. Since both for loops are same, we can also combine. We can also combine. Just say we just combine. Combine means we just combine what? We just take any one of the for loop. For I equals to 1, I less equals to 100, I plus plus. Just see, we can take either this for loop or first for loop, or we can take the second for loop. Because both for loops are completely same, we just take any one of the for loop and just copy statement 1 from first for loop here, and copy the second statement from second for loop here, statement 1 and statement 2. Okay, so that means if both loops are same, we can also combine these loops. Let's see, we just analyze. In the first case means what? First for loop case, the first for loop will execute how many times? 100 times. That means the statement 1 will execute 100 times. In the second case, the second for loop will execute how many times? 100 times. That means this code snippet will execute total 200 times. Total 200 times. But see the optimized code. Just see the optimized code. The optimized code will execute how many times? 100 times. So this is called as loop jamming concept. Okay. So we'll see the next type of independent code optimization method, loop unrolling. So what is the meaning of loop unrolling? See, reduce the number of times of comparisons inside the loop. The number of times of comparison inside the loop, okay, will reduce in case of what? Loop unrolling. So what is the meaning of the definition? Try to understand. Okay, see, this is my code snippet. I equals to 1, while I is less or equal to 100, statement 1, then I plus plus. That means the while loop will execute how many times? Means this statement will execute how many times? Total 100 times. Total 100 times. Okay. After optimization, just see, after optimization, I equals to 1, while I just take I value is less or equals to 50. But here I value is less or equals to 100. But we have taken I value is less or equal to 50. And there are two statements. Just see, in the first case means in the given loop, this statement will execute how many times? This statement will execute how many times? Total 100 times. Total 100 times. Okay, that means I value equals to 1 is less or equals to 100, then it will execute statement. Then I value will increment by 1 value, then I value will 2 is less or equal to 100, then it will execute the second statement. and in this way it will execute total 100 number of statements in this case. That means the loop will execute 100 times. But here in this case we have just taken how many? Here value is, we have just taken what, 50 instead of 100. But it will execute when I value equals to 1. When I value equals to 1, it will execute two statements at a time, means statement and statement. There are two statements at a time. When I value equals to 2, it will execute two statements. But here I value equal to 1 means it will execute only one statement. I value equals to 2 means it will execute the second statement. Okay, but after 100 iterations, it will execute finally 100 times the given statement. Here after 50 iterations, it will execute total how many times the given statement? Total 100 times the given statement. But in this case the loop will execute total 50 times. But here in this case the loop will execute total how many times? 100 times. Okay, so this is called as, this one is called as what? Optimization method or loop unrolling. Remember one thing, we can also write I value is less or equals to 25. We can also write I value is less or equals to 25. If I'll write I value is less or equal to 25, that means how many times I'll write the given statement? 4 times. Statement, how many times? 4 times. Statement. In this way I'll write how many times? 4 times. Okay, so that means remember the number of statements must be divisible by 100. And another thing, suppose I can also write 10, I value is less or equals to 10. We can also write, it's not a problem. If I value is less or equals to 10 means, so how many times I'll write the statement? How many times I'll write the statement? I'll write the statement up to 10 times. I'll write in the given loop. Okay, so this is called as loop unrolling. Loop unrolling means we just reduce the execution of the loop. That means in the given state, if I value is less or equal to 100, here loop will execute 100 times. If I value is less or equal to 50, that means the loop will execute 50 times. If I value is less or equal to 25, the loop will execute 25 times. If I value is less or equal to 10, that means it will execute, means the loop will execute 10 times. Okay, so if the loop will, but in the given loop, if I value is less or equal to 100, the statement will print, or the statement will executed 100 times. But if I value is less or equal to 50, the statement will execute 100 times. If I value is less or equal to 25, the statement will execute 100 times. If I value is less or equal to 10, the statement will also execute 100 times. Okay, but here we just reduce the number of execution of loop, okay, or the number of iterations we just reduce. But remember one thing, I value less or equals to 70, we cannot write I value is less or equals to 70, we cannot write, because 70 is not divisible by 100. But see, 50 is divisible by 100, 10 is divisible by 100, 25 is divisible by 100. We can write, but it's not a problem. But we cannot write I is less or equals to 70, or we cannot write I is less or equals to 60. We cannot write, because 70 or 60 both are not divisible by 100. Okay, so this concept is called as loop unrolling. Next concept is called as code fusion. So what is the meaning of code fusion? Let's try to understand. This is one of the nested loop. Nested loop. Just see, try to understand the nested loop. For I equals to 1, I lesser equals to n, I plus plus. Then for j equals to 1, j is lesser equals to m, j plus plus. Then it will execute the statement. See, try to understand the code. Means for I value equals to 1, and the j value will run but from 1 to but m. That means what? Means for I value equals to 1, the statement will execute m time. Similarly, for I equals to 2, j value will run 1 to m. For I value equals to 2, j value will run from 1 to m. That means the statement will execute how many times? M times. This is important. Okay. So here that means here we just run how many times? The loop means I value equals to 1, the j value will run m times. If I value equals to 2, the j value will run m times. That means here will take, means the time complexity of the given code is n and this one is for m. Means the time it will execute how many times? It will execute total n into m, means order of n into m. It will execute order of n into m, or we can say order of n square. We can say it will order of n square, okay, in the given code. Okay. So after optimization, we can just assign part k equals to n into m, means this n and this m. We just assign k equals to what? N into m. For I equals to 1, I value is less equals to k, I plus plus, and it will execute the statement. Means this code will take how many times? Order of n. That is order of, this is k. K means what? Order of n. Okay. This code fusion in the given code, this will execute, it will take around time is order of n square, and the given code will take what? Order of n time for the execution. Okay. So these are called as the machine independent code optimization. Okay. In the next class, we'll discuss about the machine dependent code optimization, or we can say what? People optimization. Okay. Thanks for watching.